Okay, so in this video, we're going to talk about circle, specifically about circumference, area, and then arc length, and also the area of a sector. Now, in grade 7, we have already talked about the formulas of the circumference and area of a circle. So again, guys, the circumference is basically is just the perimeter of a circle. So for example, you have one point A over here, and then you go around the shape, and then you go back to A, and that's just the distance of this line over here, right? So that is what we call circumference. And then the area is just like how many like squares, one by one square inside this circle. So we already got the formula from grade 7, right? So the circumference is 2 times pi times r, and the area is pi r squared. So I'm gonna give you for the unit test, I'm gonna give you the formula, so you don't really need to memorize it if you don't want to. But yeah, I suggest that you just memorize this, because this is a very basic formula that you're going to use later on in grade 9, or maybe in senior high school. Okay, so let's just go to the example for this concept of area and also circumference. Now, for example, calculate the circumference and area of a circle with diameter of 10 correct to 2 decimal place. So be very careful, guys, when you have this is circumference. It is said that, and here the formula is 2 pi times r. R is, well, if you still remember, the r here is the radius of the circle. Now, in this question, the one that is being given is the diameter, not the circumference, not the radius. So we're going to find the radius first before you go to the formula. Okay, now what is the connection between the radius and also diameter? So remember, guys, this if we're talking about diameter, it's just like from one point on the circumference of the circle, for example, point A, and then you go to point B, right? And then this point A and B is just like a chord, but it passes through the center point, right? So as you can see that, let's say I'm gonna put this center point as P, for example. So from P to A is R, and P to B is also R. Can you see that this is diameter, and diameter is just like twice of the size of the radius. So I can just write down that the diameter, right, is equals to 2 times the radius. Right, so in here we can just write down, if this is 10, so I'm gonna write down d equals to 10, that 10 is equals to 2 times the radius. And since we're looking for the value of the radius, so we can divide both sides by 2, right? And you'll get the r. So 10 divided by 2 is equals to 5. So the radius is equals to 5 centimeters. So this is the radius. Now, after we find the radius, now we can find the circumference and also the area. Okay, now let's go first to the circumference. Remember, most of the time you just write down the formula first before you calculate anything. To have to c equals to 2 pi r, and that equals to 2 times pi times 5, and that'll be just 10 pi centimeter. Okay, guys, so here this is the thing that you need to see for the instruction of the question. If it doesn't say anything about like correct to 2 decimal place, so let it be like this, because this is the exact value of the circumference. But if you are told from the question, it's giving an instruction, for example, like correct to 2 decimal place, then you need to use the calculator. Okay, so let's go and jump to the calculator. Okay, here we go. So we have 2 times pi, and then times 5, right? Okay, so in my calculator, actually you can use any calculator you want. Okay, so it's just like 10 pi, right? But I need to convert this into decimal. Using my calculator here, you have number and then convert to decimal, and then you go this. So it's 31.4159. I'm gonna write everything 314159. Yeah. So actually, the numbers keep going, but in here I'm setting the numbers only like a couple of numbers here. Let's go again. 314159. 31.4159. Now it said that correct to two decimal place. Okay, now it means that you're going to only take two decimal places. Decimal place starts from the after the decimal separator. In here we have like a point, right? So you only take two of that. One, two. There you go. You stop here. But after you see the after you take these two, you need to consider the number after that, after the second decimal. If it is 5 or more, then it means that this number here, right, the last number here, you added with 1. But it's if it's less than 5, if it's less than 5, then that number, just that number, I mean, like, you don't have to add anything with that, right? So in here, because the next number is 5 here, right? So which means that this number here, you add it with 1. We call it rounding, yeah? So that'll be 31.42. Okay? And then remember that you need to write down also the unit. Okay, now we have found the circumference. Now we are going to look for the area, okay? So again, the area, we have the formula here, which is pi r square. So remember that if after you get the value of r, right, you only need to plug in into the formula, right? So just plug in that r, that 5, into the r. Okay, remember that every time, most of the time, guys, if you want to substitute the value of a variable, so put a bracket on it, okay? And then just like put it into the calculator, and here we have pi and then bracket 5 square. And if you put it in the calculator, you get 25 pi centimeter square. Then again, guys, because in the question it said correct to two decimal place, and then we have to use the calculator again and then see what we got. Okay, so that'll be 225 and then pi. Okay, and then I'm gonna press equal sign, and then I'm going to change this into decimal to 1. Okay, guys, so 78.5398. Okay, again, because it's telling you to take two decimal place, so these two numbers, you take it and then consider the next number, which is this one here, 9, because it's 5 or more. It means that this number here, the previous number, you added with 1, so you'll get 78.54. Okay, don't forget to write down the unit. Okay, here we go. Okay, now let's go to the next concept, which is about arc length. So basically, if you understand the concept about circumference and area, this one is actually very similar to that. Okay, so what is an arc? So the arc, what is arc length? The measure of the distance along the curved line from one point to another on the circumference of a circle. So again, guys, if you have a circle like this, right? So this is a circle, and then you take 2 points. For example, this is point A and point B, like on the circumference, and then you want to know the length of this curve, right? This blue one, right? So if I just like take this one, you'll get this, right? So this is like AB. I'm just putting that there. So I want to know what is the length of this curve here, right? So that is what we call the arc length. Now, if you understand about the circumference of a circle, so basically this is just like a part of the circumference of a circle. So you're going to use the circumference formula again to calculate the arc length. Okay, so again, it said that it's a portion of a circumference of a circle, right? It's just a portion. We don't know. It can be half, it can be 40%, and it can be 0.2. I don't know. I mean, like, it depends on the question, right? But it's just like a part of it. Okay, now the smaller part is called minor arc, and the larger part is the major arc. So in here, for example, we have A and B, right? Again, so this one here is what we call the minor arc. And from here to here, right, we call it the major arc. Okay, so what makes it different? This one is smaller than this one, right? So this is the minor and this is the major. Okay, so that's the only difference. Okay, now let's go to the formula here. The formula is if you have again, guys, the portion here is just like the ratio between the angles. Okay, we know that the angle in a circle is 360 degree, right? So for example, this is like only like 60 degree. So this part here is only 60 out of 360 of the circumference, right? So again, this is just the ratio between the angle that form the arc with the 360, because 360 is the angle in a full circle, right? So if you see the formula in here, we have, if the angle is this, we read this as theta, right? So if this is the angle is theta, so which means that the arc length of, for example, from A to B is just theta compared with 360, again 360 from the angle that form a circle, right? And then you just time it with 2 pi r. Notice that this 2 pi r is actually just the circumference. So if I rewrite this equation, right, sorry, this formula, there'll be arc length is just equals to theta over 360 degree just multiplied by the circumference of the circle. Okay, so this is the very basic concept of arc length. Okay, let's go to the example. Okay, so we have an example here. Okay, so a circle has a radius of 12 centimeter as given in the picture below, like this. So the radius is 12. I can just write down this as 12 centimeter. Now, if the angle theta is equal 60 degree, I'm going to change this into 60 degree. Okay, so calculate the arc length. This one here, L. This L here. Correct to the nearest integer. So this the angle that formed by with this arc is this 60 degree, right? So we're going to use this angle to calculate the length of this curve. Okay. So again, guys, when we go back to the formula, that arc length, okay, so arc length is just equals to theta over 360 multiplied by the circumference of the circle itself. Okay, so in here again, because we're looking for the length of this curve, and this curve represented, I mean, like, it can be calculated by this 60 degree, right? Because this 60 degree represent the angle that formed this arc. So just plug in the 60 to the theta here, which is 60 over 360. Okay, again, guys, this is from here, right? And then times it with the circumference of the circle, which is 2 pi r, right? So 2 times pi times, we already know that the radius is 12 centimeter, right? So like this. Okay, just use your calculator and you'll get 4 pi centimeter. Then again, because it said that for correct to the nearest integer, so you need to use the calculator to find out what's the decimal number of this 4 pi. So I've already calculated that. That will be 12.5664 12.5664 centimeter, but it said that correct to the nearest integer. It means that we're going to get rid of the decimal value, so we're gonna get rid of these. Okay, so again, we only need these two numbers, right? That 1 and 2, which is this, again, this 12. But remember that if you round a number, it means that you need to consider the next number after you get this. Okay, the next number, which is 5. Because it is 5, then you need to add this number by 1. So you'll get 13 centimeter. Okay, let's go to the next concept, which is about sector area. So sector area is a portion of a disk enclosed by 2 radii. Radii is a radius, and an arc, where the smaller area is known as the minor sector and the larger being the major sector. Okay, so in here we have sector. So if, for example, here, guys, we have a full circle like this, right? And then I'm just like going to draw 2 radii or 2 radius here. For example, A, and this is like the center point. I'm gonna make it into P. For example, this is point A, and this is point B, for example. So I'm gonna take a radius from P to A and also to P to B. Okay, so in here we have an arc, right? So here, arc AB. So this one here is the minor arc because it's like smaller than this one. So that will be the minor arc. So the area enclosed by this is what we call a sector. Then again, because this sector is closed by the minor arc, so this is the minor sector. And then we actually have another sector, which is actually over here, right? This guy over here. It's like a Pac-Man, right? So that one here, this area here, is enclosed by these 2 radii, but in here we have, and also closed by the major sector. So this is what we call the major sector. Okay, so this is the very basic concept about the sector area, right? So in here, how about calculating the sector, right? So again, this is just actually almost the same thing like the arc length. So while the arc length is part of the circumference of a circle, what a sector, while sector is part of the area of the circle. So as you can see that previously we have this the what do you call it, the arc length, right? The arc length, the formula is theta over 360 degree, right, and multiplied by the circumference, while the area or the sector area is the theta over 360. Can you see that we have the same exact formula for this one, but you not multiplying with the circumference, you're multiplying with the area of the circle itself, right? Because it's like just a portion of that. For example, like you have a pizza, a full pizza, right, and then you only take this part, right, this part over here, so it's just like part of this, the whole thing, right, of the area of the circle, right? So in here we have the formula here, right? So the area is equal to theta over 360 multiplied by pi r squared. So notice that this guy is just the area, right, of the circle. Okay, so the concept is just like the portion of the area of the circle. So which means that you're going to compare the angle that formed the sector, and then compare that with the with 360. Again, well, why do we get the 360? Because that is the whole thing, right? 360 is the angle that form a full circle. That's why we compare that with 360. Okay, now let's go to the example. Okay, so this is the example. A circle has a radius of 9 centimeters as given in the picture below. If the angle of theta is 120 degree, calculate the minor sector correct to 1 decimal place. Okay, now in here, guys, again, it is being asked the minor sector. So the sector, there are two sectors, which is this one, this piece, and also this one over here, right? So there are two of them. Okay, so in here we are going to talk about minor sector. It means that we are going only to find the area of the smaller part, which is this one, the red one. Okay, so we're going to focus on the angle that is making the area, the sector area of this minor sector. So for you to notice that if I change this into like major, right, major, it means that you're going to find the area of this part. Okay, so the angle that you're using is not this one, instead is this one over here. Okay, so yeah, let's go back to the question here. Okay, now it said that it calculate the minor sector. Again, guys, you can just write down what is given from the question. The first one is the radius is 9, so I'm gonna write down radius equals to 9 centimeter, and then it said that the theta, the angle that form that sector, is 120 degrees. So it's like theta equals to 120 degrees. Now the question is calculate the minor sector. It means that, okay, so area of the sector is going to be equal to, write down the formula, which is theta over 360 degree, right? Remember that this is in degree, this is also in degree, because we're going to find the ratio of those two angles, and then multiply that with the area of the circle itself. Okay, so the area of a circle is pi r squared. Okay, now just plug in everything that you know. We have the theta is 120, so that'll be 120 degree over 360 degree multiplied by the area of a circle, which is pi r squared. That'll be pi, and since we know that the radius is 9, and yeah, that'll be just 9 squared. And yeah, just plug this in into the calculator. Okay, so you will get, so that'll be 27. Just put that into the calculator, guys. You'll get 27 pi. Remember that this is because this is in centimeter, then this is the area, so it'll be centimeter squared. Now, in this question, is that I calculate correct to 1 decimal place. Again, if you change this into the decimal, you can use the calculator. You'll get 84.823000165, right? So because it said that 1 decimal place, it means that you only take until this number, which is one number after the decimal place. Okay, so the 84.8, you take it, and then you consider the next number after that, which is this 2, because it's less than 5, so which means that we're going to get rid everything over here. So you're only going to get 84.8, and that'll be in centimeter square. Here you go. I'm gonna give you some one extra question here, extra example actually. Now, what if the one that's being asked, it's not the minor sector, it is the major sector? I'm gonna change this into major. Okay, now the thing that you need to the difference between the minor and the major sector is just this theta here. right? So the angle that formed that sector. So if we're talking about major sector, it means that you're going to calculate the area of this big one over here. So the angle is not this anymore, right? Because that is this smaller one. That's the minor, the angle that formed the minor sector. So for this one, you're going to find the angle over here. Let's name that with x, for example. Now, how do we calculate that angle? Now, we know that the total angle of a circle is 360, right? So, for example, from here, going back again here is 360 degree. And this portion is 120 degree. So, it's a very simple concept. So, the x angle over here, the x degree here, is just subtracting the 360 with 120, right? So, if I want to know the angle that form over here, for example, right? Let's name it again with x. So the x degree, right? The angle that x is just 360 degree minus the theta. In here, the theta is 120, so minus it with 120 degree, and that will be just equals to 240 degree. So if you want to find the area of the sector, right, for the major one, okay, the major one, and that would be just like using the same formula, but the only difference is that this guy is not 120, but it's 240 degree, right? 240 over 360, and you do the same exact thing, right? Can you see that this is the same with this one? The only difference is that it is 120 because we're talking about the minor one, the smaller one over here, and this one is the major one, so we're going to take this one, okay? So be very careful when you answer a question. Make sure that you understand the question and pay a very close attention about the details, like this one, for example, major or minor. Okay, so again, for this one, you can just like use a calculator, right? And if you take it with the pi, there'll be 54 pi centimeter square. And if you are going to take it correct to one decimal place, you will get 169.6460033, right? And then again, guys, correct to one decimal place, it means that you're only taking one decimal place, which is until this 6, right? Because that's only one number after the decimal. And you take all of these, and then again, consider the next number after that, which is this. That 4, right? So because it's less than 5, okay, again, if it's less than 5, you get rid of everything. If it's 5 or more, then you add the previous number by 1. So because this is 4, it means that we're, which is less than 5, so we're going to get it out of everything over here. So it's just 169.6 in centimeters square, okay?